Welcome to day 10. Let's jump right into a really common misconception in software engineering today. As we build out more advanced systems, it's pretty natural to assume that securing an AI agent is exactly like securing a traditional application, or maybe just a standard LLM chatbot. But actually, it's not. The rules have fundamentally changed.
So, what happens when your software decides to act on its own? That's the core question we're answering today. You see, adding autonomy to an AI model doesn't just add a cool new feature, it completely rewires your vulnerability map. By the end of this explainer, you'll understand exactly how autonomy reshapes the threat landscape and, more importantly, how to engineer your defenses.
Part 1. The autonomy problem. To get the intuition here, we have to shift our mindset from systems that merely enable human interactions to systems that actively drive business transactions. Think about a traditional static software application. It's basically a locked vault door. It's highly secure, and it just sits there waiting for an explicit authorized command to open. Now, a standalone LLM chatbot is a bit different. That's more like a really smart financial advisor sitting inside a locked room. They give you great advice, but they can't actually touch the money in the vault. But an autonomous AI agent? That's like an intern walking around your building with a set of master keys. It initiates independent actions. It connects to your databases, it reads your emails, and it executes API calls completely on its own.
Which brings us to the concept of a digital insider. Because your agent is walking around with those master keys, it operates within your system with assigned privileges. It's capable of executing independent, goal-driven actions without direct human oversight. And that lack of oversight, combined with direct API access, is the root cause of an entirely new class of security problems. Because if the agent makes a mistake, or worse, gets compromised, it does so with inside access.
So, the crucial point here is understanding how these risks compound. First off, AI models rely on probabilistic inference. They're basically guessing the most likely next step, which makes their behavior inherently unpredictable. Second, because they connect to external tools to do their jobs, your external attack surface expands massively. Third, they take autonomous actions at machine speed. And finally, if you're running a multi-agent system, a flaw in one agent can quickly chain and cascade to other agents way before a human can ever hit the kill switch. Part 2. The attack surface.
Okay, we've got the intuition down. Now let's ground this technically and look at the anatomy of an agent attack. It almost always starts with an indirect prompt injection. This is where an attacker hides a malicious instruction inside data that the agent naturally reads, like an external website or an uploaded document. Step 2 is agent goal hijacking. The agent ingests that hidden instruction and it completely overrides its original objective. Suddenly, its goal is no longer your goal. And then step 3 is tool and API manipulation. That hijacked agent now weaponizes its own access, misusing its connected tools to execute the attacker's instructions. Attackers can also play the long game here through something called memory poisoning. You know how advanced agents retain a persistent memory of their past actions to get better over time? Well, an attacker can silently corrupt that memory bank. This fundamentally alters the agent's future understanding and actions. It's incredibly dangerous because it ensures long-term, untraceable exploitation that easily evades standard network monitoring. To actually defend against this, your architecture simply has to change. You can't just bolt a firewall onto an LLM and call it a day. You have to treat every single AI agent as a first-class identity. Just like a human employee, it needs its own credentials. You also need to implement a strict zero-trust architecture where every single action is verified. You have to enforce least privilege access, meaning the agent gets the absolute minimum permissions needed for a specific task. And finally, microsegment your AI workloads. Trap the agent in a tightly controlled environment, so if it does get compromised, the blast radius is contained. Part 3. Real-world exploitation.
Let's move from the abstract to the concrete and see exactly why practitioners need to care about this right now. Consider an automated customer service CRM agent. Its intended job is super simple. Read uploaded receipts and update billing records. But look at the attacker-forced action pipeline. An attacker uploads a totally normal-looking receipt, but it contains hidden text. At the input stage, the agent ingests an indirect prompt injection. At the process stage, instead of updating the billing record, the agent suffers goal hijacking. Its new secret goal is to find sensitive data. And at the output stage, instead of resolving the customer query, it connects to your internal API and silently executes untraceable data exfiltration. Your data's gone, and your system logs, they just show the agent doing its job. Now, if you think this sounds like science fiction, just look at the data. 80% of organizations have already encountered risky behaviors from agents. We're talking improper data exposure and unauthorized system access. This isn't theoretical. It's an immediate, urgent reality for any team deploying agentic workflows.
Part 4. The core takeaway.
Let's bring all of this together. Because agents act independently, security literally cannot be an afterthought that you just bolt onto the end of a deployment. As the research notes, in an agentic world, trust is not a feature, it must be the foundation. You have to engineer that trust into the very architecture of the system before you ever flip the switch and turn the agent on. So if you only remember one thing from today, make it this. Adding autonomy creates a fundamentally new class of security risks. You aren't just securing code anymore. You're governing a digital workforce. You must treat every AI agent as a first-class identity with least privilege, zero trust access. I'll leave you with this thought to consider for your own systems. If your autonomous agent gets breached tomorrow, whose digital fingerprints will actually be on the execution logs?